Hello everyone, I am Satya Jaydev. I'll be presenting this paper on aided selection of sampling methods for imbalanced data classification, co-authored by Deep Saini and Nirav Bhatt. I'll begin with the motivation for the problem we chose. Then I will present the core solution, which is the framework for selection of sampling methods. Then I will discuss the experimental studies performed, followed by results and conclusions. It is well known that the real world classification problems are class imbalanced in nature. That is, one class samples dominate over the other. And it is very important to handle this imbalance because most of the traditional classification algorithms assume balanced data. We see that in the literature, class imbalance is mostly handled through sampling based approaches, approaches which modify the cost function, and active learning approaches. Here we will be dealing with sampling based approaches in which the imbalanced dataset is resampled to achieve some level of class balance so that traditional classification algorithms can be applied. Now we see that there are many sampling methods, of which some are shown here in this figure. And studies have shown that there is no one sampling method that works as desired across all dataset. Also, what is desired changes based on the application. Some applications might require high recall, while some applications might require high precision. And there is always a trade-off that needs to be done. Now, how to find a sampling method which meets the desired performance given a dataset and an application without having to try all these sampling methods in literature? This is what we'll try to answer through this work. So the objective is to find a suitable sampling method or small set of sampling methods which achieve desired classifier performance after a dataset is resampled using that particular method. Therefore, we try to find an objective relationship between the datasets and sampling methods via the classifier performance. So that is the approach that we propose. Here is what we do. Since all the datasets do not have the same number of features and samples, we first characterize them using a common set of meta features. That is, we map any given dataset to a meta feature space of 8 dimensions. So we have 8 meta features. We found that these features do a good job in capturing the characteristics of an imbalanced dataset. They are listed here and you may refer to them for more details. Then we propose to resample the datasets using different sampling methods and then build classifiers to predict the precision and recall on resampled datasets. So this is the second step. Finally, using the meta features as inputs and precision recall as targets, we build neural network based regression models to find a relationship between the datasets and precision recall or classifiers on resampled datasets. These models are built for each sampling method to directly predict the precision and recall without having to perform resampling and without even building a classifier. These models can be used to select sampling methods given a datasets, which we'll discuss about later. To study our framework, we performed simulation experiments to capture imbalanced datasets with a wide range of characteristics. We generated them synthetically using a sklearn function called makeClassification. This table shows the range of parameters used to generate these datasets. Then we perform the steps proposed in the framework. To validate the learned regression models, we used Kiel benchmark datasets. On these datasets, we predict the precision and recall that we would get when a particular sampling method is used. Here are the results we got. Using bootstrap sampling, we built 50 regression models pertaining to each sampling method and made predictions using all of them, and then drew box plots to capture the range of possible errors in prediction. Even in the worst case scenario, we got errors less than 0.3. So I would also like to mention that in all the models that we built, we used only neural networks. Now coming to how selection can be done, we built a Pareto set of precision recall values obtained from different sampling methods. So each point of this set corresponds to a precision recall obtained for a particular sampling method. And we call it a Pareto set because in this set, no one point can be chosen to be optimal over the other, as can be observed in this figure. So it is always a trade-off among these points, and based on the application, one or more of these points from this Pareto set can be chosen, and the corresponding sampling method can be applied. So to conclude, we proposed a framework which aids in selection of sampling methods for imbalanced data classification. The precision recall values on classification of resampled datasets are predicted with low error and can be used to choose sampling methods which achieve desired performance. Thank you.